RAM and ROM. Okay, so these two parts, if you remove, it is microprocessor. If you add, this is micro controller. Okay, so anybody is giving some message. Okay, so this is what we have, and then this is additional interrupt control, or now people basic define is CPU, bus, IO ports, then the RAM, ROM, right? So these are the things, and the timer, oscillator. So this timer, clock. So this oscillator and this oscillator, both are working together. Only for the better understanding, they are separating. So okay, and there are interrupts which are there. So this is what our 8051 microcontroller is having, right? In this case. So I'm just using the diagram from this because it is giving the proper information about 8050 microcontroller. Then we have seen that what is CPU, stack pointer. First we started understanding what is RAM, random access memory. It is a box, the way you see here. But along with that, you feel that uh, in my PDF file I have applied that grid structure, so it shows vertical, horizontal lines. So we can understand from the same concept that this RAM, or a kind of a box, is divided into many parts, right? This is called as mapping. Now you can start from 0 0 1 2 3 4 5 this way, then you can go from 11 12, next line, next line. So this way it is divided. In RAM, now we have seen the vertical division. So what happens, it will start from 0 0 0 1 0 2 0 3. So from here the journey will begin like, okay, let's see. So it will say the bottom part is 0 0, then 0 1, 0 2, 0 3, 0 4. Okay, so this is going to develop in this fashion. So you will have a 0 0 0 up to FF for 2 raised to 128. So this is 128 bit RAM. So not 2 raised to 128. Only these are the locations available, 0 0 to this, and these all locations are divided into different parts. And let me just bring it here, how they are divided. So this is a block diagram, same which is represented in the other reference book. This is all about the RAM, right? So this part is only ROM, but the other blocks are belonging to RAM area only. So from 0 0 to about 2F, right? So up to this, sorry, 1F. This is register bank. So this is register bank from 0 0 to this. Then there is a bit address area up to 2F. So this is what we have seen. What is bit addressing? Individual bit we can modify, right? Means in this horizontal section, so For the 20 address 20, it will have a 8 sections. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you can manipulate the bit here. You can put 1, 0, 1, whatever. This is called as bit addressing. Individual bit in this first memory location can be controlled by some command. Okay, so for the 20 address, to manipulate that part, you will have a one command for zero first location, then second location. So you can start from say LSB to MSB. So from LSB to MSB, 8 different codes will be associated with this 20 address. Okay. So that much fine tuning of instruction is done that it now you can manipulate 0 to 1, 1 to 0. Here you can put 1 or 0, whatever. Okay. The way our program status word is telling us that whether auxiliary carry generated, sign is generated. So in same fashion, you can address all these bits. Okay. So this is the bit addressable, and then there is a general purpose area. Now some part of it is used by the user, right? So otherwise the processor can take hold of it. Then at address 81 there is a stack point. So this is address, and this is the bit. So this is 8-bit stack pointer, and then it will have a stack also in which you have to store all these things. So this stack is going to communicate with the external. It will communicate with the external memory. Like this, and from here the data will come here into the stack, or it is assumed that it is storing the address of this particular memory location. So what happens whenever the CPU is initializing any program? In normal case, whenever you start the machine, the CPU will initialize the stack pointer. Stack pointer will jump to the address of 000 of the external memory or location, right? So it will read instruction in this, and then it will store over here. Okay, but doing this, what it does, whatever is the address of the stack, suppose it is 81, it will increment by 1, so it will become 89. Sorry, 82. Okay, so it increments its number address, and then it stores the content here at this position. Okay, then to store next, it will go with 83, increment by 1, and then you bring the data from memory here, and then it stores here. This is the uh, functioning of the stack it does, and this is what explained in this just a minute. Okay, so program counter, data pointer, AB register we have seen. Stack and the stack pointer. Okay, so what it does is that it increments the register values by 1, like this. Okay, so when the stack pointer is initialized at address 07 in the RAM, whenever the program starts, that stack pointer will increment its value by 1, so it goes to 08. Then it takes the data from the external memory address and stores it here. Okay, And when you are using that data, the processor is processing that data, again it decrements the address. It takes out the data for the processing, but at the same time it makes sure that stack pointer is decremented to one address, so it goes to the 07. So what happens, this cycle keeps on continuing. When you have a more data, it increments that much, it processes the data, but whenever it takes out the data from the stack, it keeps on decrementing the stack pointer. So benefit of this is that this is increment, this is decrement. The number of data coming and the number of data going, the values are same in terms of say quantity. Four data come, four data points come, four data points goes out. So because of which the stack pointer again comes back to the original position, and it is available for the next instruction or next program also. Okay, so this is a increment cycle while storing the data from the external memory into the stack, and then when the data is processed, it is decrementing. Okay, so this process continues for individual instruction. When you say move one number, it will take that. Then you say move the another number, again it will start from 7 to higher level. Then you say add two number, then it will take two numbers and add it. Okay, so you can see move first number into the accumulator, so the stack pointer will take that instruction and then it process and it comes to 7. Then it is available for the next instruction, move the second number into register B. Then you say it goes like this, again it takes out the data and it moves into the register B, and it the stack pointer again comes to 07. When you say add two numbers, then it takes first number accumulator, second number register B, add these two numbers in accumulator, and then means all these things will be here. And as you proceed, as you do the addition, the data will again decrement in the stack and it will come to 07. So this is a simplified way I wanted to just explain the stack operation. As you refer to different books, sometimes it will say that it jumps one bit high, means instead of incrementing, these people have shown that the stack pointer uh, jumps to the next location. So it stores some number here, then it goes to the stack pointer goes to 06 for the next number. Okay, so you have to just carefully understand in our book what it predicts, that initially stack pointer is uh, initiated at 07 address. Whenever any execution takes place, this fellow jumps to this address by incrementing number 1 in its address, and then it takes the data from the external memory in here, and then if the data is having 2 3 values in that memory block along with the instruction, then it has to come here. Okay, so this is one thing. Now whatever we store in memory, what we store in memory is important. So I will try to uh, use the pencil tool. Okay, so uh, can you guess, or can you tell me what are the contents present in the memory location? Whenever you are writing program, those who are having little bit experience of programming 8085, so what are the things you have stored in a particular program, if any?
Instruction
So
and
one
data.
is instruction. Okay, anything else? Yes, so it is an
Memory
address.
location.
Right, address of something. It can be memory location, it can be interrupt, it can be some port, external port, internal port. So uh, see, these are the three things we store in memory in the form of 0 and 1. right? Basically it is 0 and 1, or sometimes it is X number. So 0 0 to FF, right? But it is nothing but this digital code is nothing but 0 and 1 only, right? So this is what we have to understand, that whatever, even our name is stored in the form of 0 and 1, our account balance is stored in 0 and 1, our all the images. So in digital world, uh, where we are swimming every day, everything is in the terms of 0 and 1. What is the meaning of that string 0 1 0 1 1? That has to be decided by this instruction. Then either it is data or the address. So in the beginning there will be always some instruction, right? So whenever you write the program, it begins always with the instruction. Then the instruction will tell whether it is a data or the address depending upon the dictionary, right? This is opcode, machine code, language, and all these things. So you write the program in assembly language, then you convert it into machine code, and then you put it. So you will have a dictionary available for conversion of all these things, right? So once you clarify the working of individual component of the IC or the microcontroller, you will have a little trouble in writing the working or the functioning of individual microcontroller. Either you stick to TIC microcontroller, you stick with uh, other microcontroller like 88 ARM processor is there. You have Intel Pentium processor. Okay. Secondly, the architecture that we are looking at. So this is all about memory. Then architecture has two parts: software architecture and the hardware architecture. So when you go with the software architecture, you will have a CISC and RISC. Instruction set is a software, so reduced instruction set and the complex instruction set. And uh, when you go with the hardware, then von Neumann and the Harvard architecture. Okay. So in 8085, which is a complex instruction set, so you will see there is only addition command, but there is no multiplication command, right? So what it does, that if you want to multiply two numbers, then you have to add one number by second number times. Okay. So when you say 4 into 5, you give a cycle loop, add 4 5 times. But this is reduced. So the now people came out with a reduced instruction set where they have written this program as some code, which is represented by multiplication. So you just have to type 4 star 5 or 4 MUL multiply 5, and that MUL will be represented by some number, and this will once you put that instruction into your particular memory coding in the memory, that instruction will direct the program to subroutine, right? That subroutine is applicable for the multiplication. So that subroutine call will give you, so the instruction includes that subroutine call. So if the multiplication program is stored somewhere in the ROM, then it has a notification within that code. So code will direct the entire system along with the data, 4 and 5 is the data, to multiply. And then it will add that number this many times and you will get the there may be some other shortcuts that you can use, that if you do 4 into 5, so in our say 3-bit binary, so it is just 1 0 0 multiply by 1 0 1. So it is like 4 into 5. So it has supposed to give us answer 20, means it is going to give you 1 carry. बराबर है? So what is the answer of it? So when you say 20, No, it is going to get, because this is going to give you 8 plus 4, right? So this is 4, 5, 6, 7. If I have a one more here, so 8 and 15. So it has to generate double carry, right? Going to be little bit difficult task. So you will have to use byte structure, means additionally 10 here, 10 here, 4 bit. So these are the bits, but you have to use byte, means uh, 0 0 to FF structure, and then you will be able to write what is the value of 20, where it is like 0001, and sorry, this is 1 here, बराबर है. So hopefully, sorry, again I did some mistake. This is 4, 1, 2, 4. No, I'll just cancel this. uh, this is not the thing. uh, 0, it is 0, 2, 4, and this 8, and this is 16, बराबर है. So 16 plus 4 is 20. This is the answer of this calculation, right? So um, does the processor need to do the addition this many times, or for adding counter means adding 5 to itself 4 times, or adding 4 5 times to itself, or can we have some sort of a shortcut method that gives this multiplication into this? Okay, so in such case you will have to use your brain and try to find out that how I can get this answer by uh, see all this 1 2 3 4, and then 1 2 3 4. Okay, so 0 0 0 0 1 0 0 multiply by 0 0 0 0 1 0 1 to get 0 0 0 1 0 1 0 0, right? So can you twist your brain to get this answer by doing some addition subtraction, or you need to follow this process, addition of this part to itself this many times, counter and all these things. Okay, so you can just start thinking on it, how we can do it. So this can give rise to some different kind of technology technique, right? So anyways, so internal RAM is distributed into different part. Where is that? Just now we have seen this uh, stack pointer. Okay. uh,
Sir, your mic is off.
Sorry. Uh, Sorry. I just forgot that my mic is off. Okay, if you have any difficulties, okay, somebody is asking, sir, what is exactly the interrupt? So, interrupt we are going to see later on. Okay, so that we will going to see. So I will not answer right now, right? But if you just see, if you are traveling in the lift, these lifts usually works on 8085 microprocessor, 8086 or 8051 microcontroller. Whenever you press button, these are interrupts, right? Whether you are at first floor, second floor, third floor, the program is continuously running, and then these interrupts are sort of a low level interrupts which do not restart the machine, right? Some of the interrupt like reset have a very highest priority. You press the button, the machine will stop. The power button itself can be considered kind of a interrupt, or reset button is a interrupt where it stops the processor functioning, means it disconnect the power of CPU, so nothing goes, it becomes, entire RAM becomes zero, and it has to start again by loading all the program into the RAM, right? So interrupts can be delay, depends on the event. If you specify certain interrupts to note down certain delay, then they can tell you that, but these interrupts are associated with the counters now, so they will count number of events, and then they will tell you that this is what things are taking place. Like you want to count um pendulum, bar pendulum oscillation, so you set up a timer, and within that time how many oscillations are taking place, or you do opposite, you start counting with the oscillations, and you keep a track of individual oscillation and the timing. Okay, so you set it counter up to 10, count 10 oscillations, and then your timer will also begin with that oscillation. So whenever do counting of oscillation, we do big mistake is that we start from one. So uh, you start counting oscillation from zero, right? Means the moment you want to start oscillation, you pull the pendulum along one side and then mention that this is my zero. So from zero, the pendulum will go and come back. Then it will become one. Okay. But what happens normally? People pull the pendulum along one side and then they say one, then two, then three. So they miss the one zero. Means actually they are counting one less count. So you have to program like that, that you begin from zero, then you go up to 10 counts, and then stop, and then note the timing. So um, this is a device, and this has its own brain, but we are smart enough because we have developed the device. So we must understand how to manipulate that device to give us a proper output, right? Computer or the microprocessor, microcontroller are most obedient servant. So since they are obedient, we make sure that they follow our instruction. Even though people are talking about artificial intelligence, uh, in some a little bit sense they will work, but there is a very smart programming required so that this system will understand. Right? So all the living things can figure out all the things on their own, but these devices have a limitation, they cannot figure out unless you write some algorithm to figure out what is going on, right? Okay, they are smart at creating patterns, right? So they can create graphs, linearly exponent, linearly go increasing, linearly decreasing, exponential increasing, exponential decreasing, quadratic, and from that graph they can generate some formula, some equations, that these are the parameters. When I plot them, they give me the behavior. Like some people are walking, so initially they will very walk very fast. After sometimes once they lose energy, the speed will go down. So it will have a some thing like, saturation. Sometimes they will saturate. So initially they work very fast, then they slow down and they move with their own pace. Secondly, if there are some hills, then they have to slow down because they have to use more energy to climb up the hill. If they are coming down, so this way it will give you the thing, some idea that uh, if a system is moving with constant speed and on a plain ground, if it suffers with some obstacle, then automatically you can have a plot of it, right? That it is like a in terrain. Okay, so in Google Maps you will see terrain map and satellite map. So it tells you that these are hills, these are valleys, and all these things. Now same idea is used in atomic force microscope, which touches the atom, and then it tells you the surface made up of these atoms. That here there are lots of hills, there are valleys, and it plots the line, individual lines, and all these lines having XYZ information. You get a map of a surface which is in nano dimension. Okay, so these are the funny things people can do. So okay, uh, I hope you have understood the stack operation and stack pointer functioning little bit. To understand more, I can just give you some YouTube channels video also. Some people have done it. Mm. Engineering people are doing, they are understanding with their own mindset, because they want to use these processors for some functioning. So they will use their own perspective. Physics people are using for the knowledge purpose, but there has to be some basics. So application is less and the knowledge is more. There are some set of register called as special function register, and the role, these special function registers are also mapped in 128 byte RAM address from 00 to 7FH. Okay, sorry. Uh, this 00 to 7FH is register bank. Okay, these are the R0 to R3 registers. Okay, apart from them, there are some 32 registers which are used by the 8085 microcontroller called as special function registers. So the role of this register is like A is accumulator, B is arithmetic. Now the RAM address is here. Okay. So when you put this address, like to initiate accumulator, you have to use this address. If you want to do mathematical operations, you have to use 0F0 along with this. Okay. Then there is a address external memory. Okay, so if you want to use external memory, then you can go up to some 4K or 64K kilobytes of addressing. Sorry, 64K means 64,000 addresses are available. Okay, to address all this, you have to use this 16-bit. So this is 8-bit and this is storing 8-bit. Okay, so what will happen, this will store 8-bit address, and this is also going to store 8-bit, so total 16-bit. So okay, so these two fellows by combining, So what it will do, it will break the address into two parts, MSB and LSB. So lower bit address will go with DPL and higher bit address will go with uh, DPH, means higher bytes, actually bytes. So 8 bit equal to 1 byte. Okay. Then there is a interrupt enable control, right? So somebody asked regarding interrupt. So this is the interrupt enable control. If it is not enabled, interrupt will be not listened by the microcontroller. Okay. So whenever you are dealing with some external events, you have to enable the interrupt. Now external event, if you write program for lift operation, whenever somebody press the button for the lift, calling lift on any floor, then the program has to enable the interrupt enable, and then there is an interrupt priority, right? So this priority can be set by the value of the interrupts, various interrupts available on the microcontroller. Otherwise, you will have to make sure by using some different ICs also, that whom to give priority, right? So interrupt priority, when it comes to priority, it is like a comparison of two different inputs, right? Two different nodes. So automatically you will have to just consider the circuit that I asked. A is greater than B hai, yeah. A is equal to B hai, yeah. A is less than B, right? So these priorities in microcontroller already set up. So uh, there will be like level 6.0, 6.5, 7.5 we have seen in case of 885. So near about 3 to 4 interrupts, and then raise RST or reset button is there. So these fellows have their own interrupt priorities. Now you can see the reset button will have a highest priority the moment you press the button. Like in case of your PC and mobile phone, sometimes it hangs up, so you have to remove the battery, or there is a small hole, you have to press some pin in it, and the mobile will restart. It will not see what is going on, why program is hanging up. It will start booting uh, as it is, and then it will try to tell you what are the problems, right? So this is the interrupt priority. Okay. Then we have input output port latch. So this is P0, P1, P2, P3. These are the address 80, 90, A0, 0B0, right? So when you are writing program, either you write 0B0 or A0, right? Whatever is the number assigned, you have to write according to that. So some people may ask why it is not 0A0, 090, but this way the instruction set is configured, and we have to also write all these instructions. So it will understand what is the meaning of it. When you write 0B0, it says the input output port latch is enabled or disabled, right? So now P0, P1, P2, P3 are the latches. These are the gateway like ports, right? On the ports or your airports, people can come from one country or they can go out to other country, right? By having proper documentation. So these latches are buffer. They communicate with the internal, external world uh, on behalf of the CPU, but also they protect the CPU from damaging, getting the damaging signals, right? So whenever they feel the threat that some signals are very high value, low value,
Sir,
yeah, yes,
sir, we want break of 5 to 10 minutes.
okay, you want break for 5 to 10 minutes. So
Sir,
those who
everyone wants.
everyone wants, I am
Yes,
just
sir.
waiting. Amay tadfale. Okay. Actually, I have to leave. So, anyways, this is 1 hour, so you can take 5 minutes break. I have to finish
Okay, sir.
earlier.
Thank you.
Maybe around 1:15 I will leave. Okay. Okay, so you joined as fast, so I will take half or half an hour more, and then I will leave the class also.
Okay, sir.
Yeah. So by the time you take break, those who are having doubt, we can have a discussion, right? Or because everybody leaves, then I will not understand what is happening. Again, I will have to admit everyone. So for 5 minutes, so 12:35, this is what my clock is telling. So we'll start at say 12:40. Okay, 40:45. So within that time, those who have some
Okay, sir.
difficulties discussion, they can have a chatting. Okay. Okay, those who are on live session, I will stop recording this, and what I will do, I will run this small video